Hi there. I'd like to start by asking a little bit of a philosophical question, and that is, well, what's in a name? Why do we put so much importance on names? And this might seem a little abstract for a data science presentation. So I guess more specifically, I want to know, well, what's in a place name, and why do we put so much importance on how we refer to locations? And I'm hopefully hopefully be able to answer this question in this presentation. So I'm Oscar. I did my fellowship project with faculty's government business unit on fuzzy location matching. So back to our big question, well, the events of the last couple of months have actually thrown up a really interesting example of when a place name really does matter. So this is the campaign to move towards the native spelling of the Ukrainian capital from Kiev to Kiev. But what if we had an automatic detection system to monitor social media posts referring to the Ukrainian capital? When this switch in lexicon occurred, would our model be able to pick it up and still understand that the Ukrainian capital was being referred to? And it's exactly this kind of challenge that I've been addressing over the last 6 weeks. So I've aimed to build an analytical tool which identifies variations in location names and match them to real locations. So what does this look like in practice? Well, the human eye can probably determine that Kiev and Kiev may well be talking about the same place, while Kiev and London probably isn't. And what I've aimed to do is to automate the ability to differentiate between those cases. So how have I gone about this? Well, my approach has centered on the use of similarity metrics. So these are quantities which encode the degree of similarity between words. And there's a variety of different similarity metrics that one can use. This is an example of just one called the Levenstein distance. And this measures the number of operations that you have to apply to the letters in a given word to reach another word. So these can be substitution, insertion, deletion of letters, things like that. And obviously the more operations that are required, then the less similar the words are. And so using a variety of these similarity metrics, I was able to build a similarity-based matching model to match an input word, which might be a variation on a place, to a real location. And so it works a bit like this. So we take our input, which we'll stick with the example of Kiev, and then I calculate the similarity metrics between the input and all potential matches. So in this case, a long list of standard city names. I then built an outlier detector, which asked, well, are there any potential matches which produce similarity metrics that are significantly different to the other potential matches? And if one of these outliers is detected, then we can be relatively confident that a true match might be obtained, in this case, Kiev and Kiev. And this relatively simple model setup is able to perform relatively well. It outperforms an out-of-the-box fuzzy matching algorithm, which is available in the Python library. But this model does actually have one pretty large pitfall, which is that just because the similarity metrics associated with one potential match are different to the others, it doesn't necessarily mean that there's a true match, a true in the sense of a Kiev versus Kiev, actually talking about the same place. And actually, I realized that I could be a little bit more sophisticated with my matching, and was able to train a random forest classifier to recognize cases in which a true match has occurred compared to where there's no match found. So when the input word is so dissimilar to any of the potential matching words, and it was able to distinguish between these cases based on these similarity metrics. So well, that's all very well, but as usual, is this making government work any easier, and who really cares? And actually, it turns out that a lot of government projects really hinge on the effective treatment of named location data. So that's data embedded in text. And so there's some really interesting examples here of potential use cases. So address matching, how many times have you entered your address in an online form and accidentally included a very small variation and it not get recognized? So this fuzzy matching could correct that. I've already mentioned the ability to locate social media activity that's mentioning locations in the case of Kiev and Kiev. And finally, and probably most topically, is official document correction. So, for example, if I'm a Ukrainian refugee who's filling out an emergency visa form, I shouldn't be penalized if I use a small variation on my hometown or my home city. And so this fuzzy matching could correct variations based in locations. And this could ultimately lead to more efficient government in the face of one of the largest humanitarian crises in many decades. So thank you very much for listening. And if you're interested in finding out more about the model or data, then feel free to reach out.